Welcome to this tutorial about AI and more specifically about behavior trees. So we're going to be building upon the episodes previously about perception and making use of them inside a behavior tree today. So let's just jump into it. So here we are inside of Unreal Engine 5 again. We're continuing from before. Now again, this works just as fine in Unreal Engine 4 as well. Did I say Unreal Engine 4 or 5? This is 5. It works in Unreal Engine 4. Everything is good. Great. Okay, so we have earlier created a few things. We created an AI character, an AI controller. We made this distraction device, not relevant today. And we also created this behavior tree and this blackboard over here. So what we can do is, first of all, we can open up the behavior tree over here. And it seems I didn't even add the blackboard last time. We can drop down the behavior tree over here. We can click drop down and choose the BB Basic that we made earlier, just so we have it. And that particular blackboard, as you can see, has the self actor here now. So to describe it a little bit, a behavior tree is a tree to symbolize or structure how an AI character is supposed to move around and work in the world. It has two very basic components that it can use. First of all, it has the root here, which is where everything starts from, and from here you can drag off and add other components. But the two most common and simple ones are the selector, and we also have the sequence. Now, generally speaking, the first node that you always bring out from the node here is likely to be a selector, and sequence is usually what you have as sort of subtree nodes. The reason for this is these have slightly different behaviors. If we were to do this and type in sequence, these themselves, okay, let's try and keep this as basic as possible. First of all, you can see that these have numbers here, 0, 1, 2. These represent the order in which they would be doing things. So if we were to add something down here, like a task that says move to, you can see that it has gotten this here, the number 2 now that this one had before, and this one is 3. So what it will be doing is going down here, down here, down here, and then it would be going down here in that order if the execution allowed it. The selector works in the way that it tries to find a task that it can do, and then it will continue doing that. So, for example, in this case, it has two different things it can run. It has this one. As long as this is going fine, it will keep doing this one. If this one at some point in time reports something has gone wrong, or it couldn't complete its action, then the selector will react to that and take the next task available to it. And then it continues like that. So if it had multiples like this, it would go do this one as long as it can, but if it fails, it tries to do this one. If this one fails, it would try to do this one, and then it works in that order. Sequence works slightly different. Sequence tries to do everything that is underneath it until it ends up with a task that fails. Then it will send that information upwards in the tree. So if we had something like, let's see, we had another move to, and we had another move to over here. That's not make noise, fine. So it would say it wants to do the move to, it wants to do the move to, it wants to do the make noise, then it wants to do the move to, it wants to do the move to, it wants to do the make noise. This is how the sequence works. It wants to do everything in sequence, and if at any point this one was to fail, it would send it up here, and this one would send it to the selector saying I failed, and the selector would try something else. So the good thing about this is it might be feeling a little bit difficult, but this is something that you get the hang of after doing some trial and error, most likely, and getting used to it. You do have the benefit of being able to see this tree in runtime while your AI is going about and doing its things. You can see which of these different roads are being pulsating, and you can see how it's like changing between the different ones. In addition to that, you also have, when you run like this, actually let's get rid of one of these characters, like so. Let's move this one out of the way for a bit. Like here. Okay, I have apparently done something with... anyway, doesn't matter for now. We'll clean it up in a moment. We can actually, I do want to see this. I want to show this. Alright, it's because I've added the blackboard tree. So you can see, although it might not be super easy to see, you can see that we have the category debugger for the AI and the behavior tree activated. What this does for us is we in the top left there you can see the category AI. We can see the controller for it, the pawn, and this is the one that we're currently exploring. And if you had the multiple AIs, you could mark them in the world outliner to the right if you wanted to see the information for a different one. You can see what kind of movement modes it has, if it's following paths, what its active tasks are, and all of that. Beneath that you can see the behavior tree. And this is, let's see if I can get the behavior tree here as well. Like so. Okay, it might be a little bit small here for you to see the text, but hopefully it's not super important what it's actually saying for now. So we go to the third person character over here. So you can see that this which is happening over here is representative of what it's actually doing here. And you can see that it's pulsating through this very, very rapidly. And you can see that it's going through the root, it's going to the selector, it's doing a move to, and it's feeling that it has done that properly. It's doing another move to, it's feeling that it's doing that one properly. And then we have the make noise over here, which is why we were getting the information. And let's see if we can get this debug. So you can see the 0 false, which was the site, if you remember, and the 1 is true. So it's actually reporting on its own noise making currently right here. So it's doing all of these tasks. And you can see that the sequencer over here is doing all of its tasks in sequence. The selector, however, is never getting to this point. Although it's not super clear, I guess. If we do it like move to, since these don't actually have tasks under them. So. So now you can see that each of these different branches have tasks to them, but we never reach these ones because this sequence is never reporting an error, which means that the selector over here is never gonna try to do the next part of this and continue onwards. So that's how that works in a nutshell. Now the behavior tree is like it sounds, the tree of behavior, but to have it operate in different ways that are seemingly intelligent, we need to have variables to work against, and that is where the blackboard comes into play. And here we have the blackboard, and we go and open our asset for the blackboard over here. By default it always gets the self-actor key here, but we can add new keys if we want to. And a key here is just a variable actually. So if we were to add something like enemy location or something like, oh, what am I doing? I want to have a vector. A vector is a 3D point in space, so enemy location, for example. You can see now that we have a vector available to us here. We can have some information changed for this if we wanted to. If we go back to the behavior tree, save, okay, it doesn't update apparently immediately. Let's open it up like so then. Maybe we have a refresher, I don't know. Okay, anyway. So now you can see we have an enemy location here as well, so we can store information in the blackboard to have this logic work on. And did I close the blackboard as well? Oh, okay. Well, another way to walk between them is just going through these different tabs also, if you want to. It makes much more sense. And that's probably why I thought I closed it down, because it just keeps one of them open at the same time. Anyway, so yeah, so here you can have, this is sort of the brain or knowledge base where you place all the information. So this is where you place things that you want your behavior tree to react on. And important to note is that this is information that is per brain. So if you were to have two AIs, they could have two different enemy locations. Or they would have different enemy locations based on their senses and how you set them for them. You can, however, have some kind of hive mind behavior if you want to make sure, like, if one enemy detects you and then you want all of them to be alerted, then you can have that kind of behavior happen also if you wanted to. But generally this is information that's kept for one specific AI. And also the trees are also executed individually on each of the different AI pawns as well. So how do we make use of our perception information that we have done in the previous episodes to make use of here then? Well, we can, for example, if we go to our AI controller, actually let's start with making a let's make a key for a boolean to see enemy spotted, something like that. And then we have a AI character over there, and let's see here, we have our AI perception over here. So if we were to we can keep the print string for now, it's fine. So we have the successfully sensed over here. If we have perceived someone to be successfully sensed, then maybe we want to react to it and say that we have spotted our enemy now. So what we can do is we can do a check. We can loop. Let's do it like so. And then if we have sensed someone successfully, let's do it like this actually. We want to type out all of our messages regardless. So let's just keep that as our debug information. Like so. And then after that we can have a branch. You can hold on B if you want to create a branch. Then we get the successfully sensed over there. And if it's true, then we can type right click here and we can type in get blackboard. Now, since we are in an AI character, it will be able to get its controller, which is running, if you remember, a behavior tree. And then from the behavior tree, you have a blackboard coupled. You only have one-to-one relationship between these two. So that's how we get this information. So now we have a blackboard here. And from a blackboard, you can set value as, and then we can have the different types of variable types that we can set. So if we do a set by bool, for example, since that is our enemy spotted, and we can say that it should be true in this case, that's all fine. But we need to define which boolean this is. Since this is unspecified right now, it needs a key name, and the key name represents whichever name you have for the different variables here. So enemy spotted is the key that we have in this case. Let's go back to our AI character. Let me drag off from this. And let's do a literal, I guess. Copy paste, something like that. So what will happen here is we will get a perception update at some point. We will go through all the different actors that have a perception update available for us. We'll go through all the different senses that we have for this specific pawn, and we will check, has any of them successfully sensed the character? And if it has, it sets this to true. So if we were to go in here and play now, we want to probably get rid of the making noise here, because it's clogging up our debug information a little bit. So like so. So let's do the apostrophe. You can see that the character is running. You can also see, which I didn't mention in the beginning, in the middle of the screen, just above the head or near the head of my character, you can see that it has blackboard, and you can see which blackboard it's using, and you can also see the different variables that it has available to it and what they're currently set as currently. So you can see that it has a reference to itself for the self actor. It does not have an enemy spotted bool set to anything else than false. It doesn't have an enemy location currently. But if we were to move inside here now, you can see that it says enemy spotted true. We have now managed to get inside of its perception and send to its blackboard that this boolean is now true. So now we have some information to act on. So let's act upon it. Hopefully you found this video helpful. If you liked the video, leave a like. If you did not like it, leave a dislike. Leave any suggestions or comments you have down below. Subscribe and share this video if you want to see more like it in the future. That is all for now. Keep on learning. Take care.